Periscope or LinkedIn Learning, and you're wondering where the conversation is and who's this guy talking to, there's a good chance I'm talking to the people over in Discord or in the YouTube chat. That's where. Let's see, any announcements and things. One thing I want to mention is our jobs board. We have a jobs board right over there at jobs.adafruit.com. And if you head over there, you can see open positions such as these. There's a tech lead for Hack Club Bank. There's a CircuitPython programmer needed for some contract work in Buffalo, New York, or it's remote work, I think, actually. But you can check that out for more details. And our job board is entirely free. It's free to post positions up there, and it is free to look around and look for work. It's also free to post your resume with your skills so that people may find you and find a making connection of some kind. So that's our jobs board. It's right over there at jobs.adafruit.com. Let's see, one other thing I wanted to mention is AdaBox. So you can sign up now to get notified for, or to subscribe to receive the winter AdaBox. It's going to be AdaBox 21. And as you may have noticed, we've gone seasonal with these. So we're not calling them a particular holiday. Instead, it's a season, and it also reflects the realities of the sort of mushier timelines on shipping and receiving parts as we put these together. But I think we're looking at a January timeline. This is not going to be there before the Christmas holiday season. It'll be sometime after that. So we're thinking in January. Did I say July a moment ago? January, February, somewhere in there. So winter. Winter AdaBox, if you head there, you can subscribe. You can also sign someone else up. And these do sell out. So if you're thinking you're interested in getting whatever that hot, new, cool, fun thing is going to be and all those great projects you'll be able to build with it, then head on over there. Head to adabox.com or adafruit.com/adabox and sign up. Let's see. Other things to mention. I've got a show I do on Tuesdays, and this is the... Oh, someone said there were no bleeps and bloops? That's weird. I thought I played some bleeps and bloops. Sorry about that. I'm sure I did. I wonder why we didn't hear them. You can hear me, right? Listen, here's some bleeps and bloops. You heard those, right? It'd be good to know if that's still working. I hear them. I hear bleeps and bloops. Also gave me a chance to get a delicious sip of water. Let's see. So I was talking about my show on Tuesdays, which is the JP's Product Pick of the Week show. And each week I pick a product, either something new or something special from our back catalog of great stuff. And I feature it. I go over how to use it. And we take a look at the learn guides that are associated with it or data sheets. And there's always, almost always, I think always, a great discount with that product pick. This past week it was 50% off of this most excellent latching relay featherwing. Now I've got a little 1-minute recap that I'd like to show you. It is the latching mini relay featherwing. I have a 24-volt power source that powers a ring light. The power comes from essentially the wall transformer to the featherwing, and then when the featherwing is closed, it will send that power along and over to the device. If I press A, that closes the relay, and you can see the big glow on my face, and then I can press a different button here to change that state. And like I said, if we put this into the latched closed position, it is going to stay there even if I kill power to this whole little setup. So I'm going to yank the power going to my feather. That means that this is not energized. It's not staying closed by virtue of a magnetic coil. It's staying closed because it has this little internal mechanism, a mechanical switch. It is the latching mini relay featherwing. Yeah, that's right. So I know a bunch of people got those. I believe we sold out. So we'd love to hear what kind of projects people are using, what kind of things people are putting together with those. Also, there was a question in the chat last night during Ask an Engineer. I don't know if it got answered because I wasn't able to finish watching through to the end of the show. But someone asked about, on the latching relay feather wing, what happens if you basically tell it to open and close at the same time, because it's two separate pins. Who wins? Do the coils just fight? What happens? So I'm curious if anyone tries that. I sort of tried it and it seemed to get stuck a little. So I think it's probably a terrible idea. There's probably a chance you can break it or at least get the switch kind of caught in the middle and then it might not want to return. So I'm not saying to do it. I probably wouldn't do it, but if anyone is curious about doing an experiment on it, let us know what you come up with. Let's see. Also, I think it's time to jump into CircuitPython Parsec.
CircuitPython Parsec.
All right, let's get set up here for this one. This is a kind of cool one today, I think, a very useful one. So for the CircuitPython Parsec today, I wanted to talk about named keyword arguments for function parameters. So these are kind of two names for the same thing, either named arguments or keyword arguments. And let's give a little background on here. So in CircuitPython and in regular Python, we can have a function, which is a little discrete chunk of code that we can define, and then we can call it later when we need it. And often there are parameters that that function can use to alter the behavior you're asking for. These are called the arguments. So when we invoke this function, we can tell it to run a particular set of arguments on the function. So if you look at my example here, I have this breathe, which is these LEDs, these two LEDs, neopixels actually, that are pulsing sort of on and off. And I'm using the defaults right now. So one thing we can do is provide no arguments at all if we have built in some defaults, which I've done here. So by default, the maximum brightness is 128, and the speed that it takes to go up is about twice as fast as it is to come back down. And if I want to call that with arguments, I can just run it like this. So here we see breathe. I'm going to change that maximum to 64. I'm going to change the speed up to 0.007 and the speed down to 0.005. If I resave, you'll see what that looks like. And so we've now got a sort of faster pulse and it's not getting quite as bright. Now, these are called positional arguments because the functions are in a particular order that is expected by the function. So now let's take a look. If we do a set of named functions, it's a little more useful, a little more helpful, because it's almost like commenting your code. Now I can call the function and say, let's set the max to 32, the speed up, the speed down to whatever those values are. If I hit this, you'll see it's going to save. It's actually going to be a little faster because it's only going half as many steps now and it's not as bright. And there's a couple of other cool little features of using these named arguments. If you look at this example, it actually doesn't matter what order you put them in because the function can tell by their names where they go and how they're used. So here I've placed that max value on the end and it's still going to work. If we tried this with positional things, we'd be throwing weird numbers that we didn't expect. And you can even pick and choose the ones that you want to send. So in this final example I have here, I'm going to use whatever the defaults are by the function, except for I'm overriding the maximum value. Instead of 128, it's going to be 64. So if I save that, you'll now see we get a slower pulse, but it's actually twice as fast as that default that we had at the beginning because we're going only half as bright. And so that is how you can use named keywords or named arguments. Let me say that again. That is how you can use keyword arguments in your functions inside of CircuitPython. And that is your CircuitPython Parsec.
CircuitPython Parsec.
All right, so someone said, wow, that was loud. What was loud? What happened? That was a couple minutes ago. Was it the volume on the CircuitPython Parsec song? I'm not sure. Is my volume's sort of a normal level, isn't it? I can turn me up just a touch there so that there's not such a disparity. But tell me, Dexter Starboard, what was loud? Because I would like you to have the smoothest possible listening experience on this show. All right, so let's see. Oh, and I should mention on this little example here, because it's somewhat mysterious what's going on, I just have one of our little Trinkies. This is the capacitive touch Trinky. I'm not actually using the capacitive touch in this case, but it's a very convenient little board. You can see there, you can just plug it right in and into a USB port or a port extender, and then I'm just putting some diffusion plastic on top of it so it's a little easier to see. Yeah, so Dexter said the CircuitPython parsec intro sound was loud. All right. Sorry about that. Okay, so let's see what else is going on. I wanted to mention, because I had gotten this wrong on my Tuesday show. I said, "Hey, I'll see you next week." Not true, actually. I'm gonna be off for Thanksgiving break next week, so the Tuesday show and today's show, the Thursday workshop show, won't be happening next week. I believe there are some shows happening next week, but stay tuned. Check for blog posts. I think PT mentioned their plans last night on Ask an Engineer, so you can go back and watch that on YouTube, on the archive, to see what the plans are for shows next week. And then I'll be back the following week. So next week, Thanksgiving break, I will be off. Let's see. Next up, let's get back into the project that I was starting last week, working on last week, and I've continued to do some work on it both in software and hardware. And that's this Pip-Boy over here, the Pip-Boy 2040. This is the build part 2 of that. So I'll talk about a little bit what I'm working on and where I'm going with it. So if you didn't catch this last week, or for a refresher, this is a featherwing tripler with a feather. I've got the RP2040 and the Joy featherwing, which uses the stemma over I²C to sort of figure out all the button and joystick stuff on the board and then just send data over I²C to the feather. So it makes your code nice and neat. And we'll take a look at how some of that code works for things like asking for button presses, asking for the joystick position. And unlike last week, I actually have that joystick doing something. I think maybe we looked at just values, raw values coming off of it. And if you recall, a couple weeks ago, I showed that nice round rectangle display that you see there. I still have the other one on this little breadboard here. So this was this lovely little round rectangle display, and it inspired me to, since it has kind of that 4:3 ratio and those rounded corners like an old CRT, little tube display. It kind of reminds me of the Pip-Boy from Fallout. In fact, I'll throw an image back up there because not everyone knows what the Pip-Boy is or the Fallout games. Let's see, Pip-Boy. And you can see some images there. So it's a wrist-mounted gizmo inside of the Fallout world. There's been a few different iterations of it, different shapes of it for different styles. And these have been made by people, including the Ruiz brothers, as Raspberry Pi projects. So I wanted to do a much sort of smaller version of one of those using this display here. So let me show you what it's doing right now, and then we'll talk about how it's all working, take a look at the code, and where it's headed. So first thing to mention here is that I had, last time, I don't think I still have that one here, last time I had a couple of zip ties to connect it to a watch band, and you'll see now I have the beginnings of a case here. So I started by designing and 3D printing a little sort of gently curved for the wrist little shape there that the board can sit on. And yes, it's big, but a lot smaller than the typical Pip-Boy. And this, I designed it with a couple of slots for a watch band to fit into, as you can see there. And in fact, let me take that off for now. Now I've also just this morning designed and printed a little top for it, and I just have that screwed onto with nylon 2.5 millimeter hardware onto the feather wing the display, and that's actually nice for keeping the display from wiggling, because otherwise I've got it going into some header pins there, so it's not as stable as if it were soldered to the board, but I want it to be removable for fiddling around with it and repairs and things. And then this whole sort of top section, including the feather wing, which drops down on top of the feather there, does in one spot right now connect up to the board and the wrist mount using some more hardware, using some standoffs there. So I'm next going to be working on sort of tying those together with a sort of wall that goes around this. Maybe that'll be one part of the display. I've also added, if you can see it there, let me zoom in a little bit. I've also added to this, I don't think I had this last week, this little on-off switch, and so that is connected to the engage, or rather enable pin that's on the feather, and it just ties the enable pin to ground when you flip it on. When you open that circuit, it allows it to start up, in this case, off of battery. I have a LiPo battery connected to the feather and under there. And you'll see here it goes through a little boot sequence. Actually, let me run that again. So I'm just going to turn this off unceremoniously and flip it back on. You will notice I do still have the screen protector on there. Just going to leave that on until I get the kind of final case. So you can see we got our little Pip-Boy logo, some startup stuff, our little display for information on here includes things like stats, inventory, data, map, radio, and there's a little bonus game here. And I've also got the cursor enabled here. So what I'm using the 4 buttons for is navigation. If we go down, for example, we're picking different items in the stats page, like that. If I use this joystick, it's now moving this little cursor around. It's a little bit sensitive. Let's see if I can do anything to dampen that motion a little bit. But right now it's essentially remapping the value of the joystick, which is 0 roughly to 1023 in each axis, to a little bit less than the width and height of the screen, just to accommodate for the size of the cursor so it doesn't fly off the edges. So I think I have it going from 0 to 264 on the right, because I have a 16 pixel cursor, and 240 minus 16 for the vertical. And that doesn't do anything, it just looks cool. Now this is a spring-loaded joystick, so you can see it returns to the center when you leave it alone. And one thing I'll mention before it happens is that I have a memory leak, or some sort of memory allocation error going on sometimes with the graphics, and I'm going to be talking with Scott and Dan about that, and anyone else who's knowledgeable about what's going on, because it's just on the edge of running out of memory sometimes, and then when it does, it'll crash. So when that's happening for me right now is during image loads. Even though I've got the images down pretty small, it's still having issues sometimes. So we may see that crash, and we'll talk about that more in the future. But enough preamble, I'll try going to the right with that. And so what that's just done is moved from the stats section to the inventory section. So now I can move down. Okay, there's the crash. Glad I warned you. I'm just going to hit reset. And each right or left is just going to move between these tabs, and then up and down moves through the screens in those tabs. And they have differing numbers of screens of information there. So if I go to the right, inventory, data, and go to this map, go to this radio. Now if I go down, I'll go to the other station, or back up. Go left again to the map. I've got 3 screens of map on there. So it's essentially just sort of a clicking around slideshow. I'm not trying to have it do any real stuff. I'm not trying to really use this cursor to navigate, because that actually kind of be a pain. So I consider this more of a prop than anything else, just a kind of cool prop for some sort of a cosplay thing. But I think the platform might be cool for people who want to add to it. You could, for example, use a feather that's got Wi-Fi or Bluetooth, and then be able to incorporate data from the outside with it, or send data from it, which would be pretty cool. And one other thing that I'm working on is, I don't have a game there, but that looks kind of cool. It's just a screenshot. One thing I'm working on is the color palette. So in, I think it was Fallout New Vegas, the color palette was kind of an amber type of palette, sepia type of palette instead of this green screen palette. I think what I'm going to do is make this be a startup thing. So when you launch it, you can pick which one it's going to be by holding down or not holding down the select button. That's another cool thing about this Joy Feather Wing. We've got these navigation buttons, we've got this joystick. This is a reset that's tied to the reset of your feather, and then this is the select button, which is just another general purpose button on I/O that goes over I2C via the seesaw. So that one's available for other stuff. Could be an enter button. What I have it doing right now, just for testing, is it changes the palette of the screen. I don't have it changing the cursor because that was giving me some trouble, but the palette is being shifted essentially, swapping the red and the green values. And since I have a mostly green, then it goes to a mostly red, but it's got sort of shades to it, so it looks a little bit more sepia. Of course, another method you could use for this is just pre-make your graphics to have two sets of them, which may make more sense. You could be a little more fine-tuned about it, I think, than palette swapping, but palette swapping is kind of neat. It means that we're reducing the amount of memory required to store all the images that are on here. Cursor still works, but it's not switching colors right now. And I think that's all it's doing. Yeah, so select should bring me back to my green screen palette, and now I can go flipping through the images. Nice that I've got it to be pretty stable. That will curse it right there, but it's not crashing too much right now. I think it's a time to go and check out the code for this. What do you think? So I'm going to put this back in here. And you could, of course, customize this for different types of watch bands or wristbands, Velcro things. You could sew it into sort of the sleeve of a coat if you wanted to. I'm just going to break it. My very thin test print here just snapped, so the top of the band is no longer connected. So let's go take a look at the code, though. And what I'm going to do is head to this view. And let's see if I can get that glare off of there. I have to prop it up. That's pretty good. Let me focus that for you. Just like that. So code on this. Let me go ahead and open that. And I will unplug my other device so that we don't have any confusion. Oh yeah, and plug this in. And I forgot, I've been using a kind of cool 90-degree angle cable, which I left back in my inside studio. But the little right angle USB-C cable is kind of a cool one to plug in here instead of this straight cable. Just could be kind of cool if you have this connected to a device, or if you're running off of a USB battery bank, that kind of thing. So now we should be able to open up the code from the device. And just because I'm accessing the disk, it's going to restart itself when I do certain things inside of Atom. Oh, I'm seeing a question I missed, earlier from Rebecca Wilson about the product pick show. Yeah, that happens at this time on Tuesdays, so it's 1 o'clock Pacific time, 4 o'clock Eastern time, so same time as this show. And if you head to our blog, there's usually a blog post before each show, as well as in our Discord, you can type in !show times, and you'll get a little schedule that'll print out for you. All right, so, whoops, there's my code. Okay, so some things I'm doing in here to talk about. First of all, since I am trying to stomp out these memory errors that I'm running into, you can see I'm importing the garbage collector. Remember, I talked about that last week. To check your free memory, you can also use the collect function of that. So you'll see it right here when I'm toggling the image. I'm doing this garbage collect, which is supposed to be freeing up some memory that was being used, and I think that's what's possibly not working. That was Lamore's hypothesis, is that it's not aware that things are being released to clean them up. So I'm also bringing in the map range, which is a math from the simple math library. It allows us to take one range of numbers and turn them into a different range of numbers, which is super helpful. Like I mentioned before, I'm reading the joystick, which has one set of ranges, and I'm applying that motion to the cursor, which is the screen dimensions, so a different set of numbers. We got display I/O to display stuff, seesaw so that we can read the buttons and joystick on the Joy Featherwing using image load, and then this is the driver for that display. Setting up seesaw, setting up SPI for the display. I set up the display and the sort of screen context, and then this is this little toggle thing. This was created by Todd Kurt. I was asking him if he had done any palette swap stuff inside of CircuitPython. I realized I thought I had done it, but no, I had been doing it inside of Make Code. There were some cool palette swap things I did maybe a year or two ago on some of our arcade, Pycade and other boards, where you can essentially color your images with a grayscale or whatever you want, and then just say this one palette, I'm going to swap it out for a different palette. So it's a sort of old video game technique that's used in a lot of other places, super efficient. And this was the way that Todd came up with after just a little bit of experimentation, which was creating this palette that essentially swaps out the RG values for each other. So red and green become green and red. And that's how we're getting this little change into amber, which does not show up on the screen too well, actually. Let's try a different page. Yeah, I think my display is a little bit blowing that out. Let me see if I can drop that exposure. Oh, auto exposure got turned on. That's no good. Turn that way down. Hey, and there's our crash. You can see, if you read that, it says memory allocation failed, allocating 33600 bytes, which is the size of one of the images. So that's my first clue as to what's going on there. So let that restart. And I'll show you, I can also turn that palette swap on from the beginning. If I resave this, it's going to restart now. And it's going to apply that palette swap. So you can see all the screens, even the startup screens, are in that amber look, which, yeah, is super washed out on the screen. So sorry about that. I don't think I can. Oh, it's doing auto white balance. That doesn't help us. I can kind of hint it a little bit that way. And see, next up we have an image being loaded as the background, and at first I just load up this one called boot pip 0, so that's I'll show it to you right now. That's that first Pip-Boy logo. Then I'm gonna create the cursor, and so if the cursor on is true, so this is a way to not have the cursor if you don't want it, then I'm also bringing in one of these two, either the amber or the green cursor. So in this case, I just made two different bitmaps. And I want transparency for that. So as you can see, this is a little triangle that's essentially got transparency. There are pixels, even though it's saved as a sort of rectangular or square image. There are pixels that are not showing up. And the way that works is it is creating a transparency from the first color in the palette, which I think I have it as magenta. But as long as it's not a color I'm using elsewhere, that first palette color gets knocked out, which is great. And then that's added to the tile grid and the screen context. And then its position, I'm just setting it off to 0, 0, which is the upper left corner, to hide it during boot up. And since the first 20 pixels or so are cut off by this rounded rectangle display, you just won't see them. You don't even have to take them sort of to a negative value off the screen. 0, 0 just makes them pop off the screen. Later, they'll show up, and I'll show you how that works. Then we have some of our code that I'm using to toggle that amber color when I press the select button, show the display. And then this is the sort of data structures that I'm using to go through the screen. So the first one is the simplest. So this is this boot file names, which is a list of these, 7 images. So the boot pip 0 shows up again, and then I run through each of those sort of little text screens as it starts, and then our little Vault Dweller guy giving the thumbs up. Does he have a name? I can't remember. Someone tell me in the chat. Does the Vault Dweller dude have a name? The little blonde guy in the jumpsuit? What's his name? I gotta find my Discord chat to see if someone answers that. Where'd you go, Discord? There it is. Oh my, just a brief look at what's happening over on Discord. We've got a Lars converted for Pip-Boy use. Love that. So the next image set or list that I've created here is cursor file name, and this is for toggling the cursor back and forth between 2 different image names if I do it that way. And this is a work in progress, so some of this isn't being used right now. And then this is the sort of most complicated one. This is the dictionary that I've created for the different sets of screens. And so the reason I felt this was necessary is that I have these tabs. So there's 6 of these tabs, which are the stat, inventory, data, map, radio, and then that sort of bonus game one that's off the screen there. The first screen has these 9, the first tab has these 9 different screens. The next one only has 2, the next has 3, the next has 3, the next has 2, the next has 2. So that's these little sets of images here. You can see I've also kind of named them for how I'm using them. Zoom into the code a little bit more. And so you don't necessarily have to do this with a dictionary. You could do it a little simpler, but I was thinking of using these names instead of numbers here, having like the inventory stats data and being able to refer to those by name also. And so since I have that set of essentially lists inside of a bigger list, I can later in code ask for the length of one of those sets of lists, and then I know how to loop through them. If I look at more than 2 images in a tab that has 2 images, I kind of roll back up to the first one. So that's how I'm using that and why I'm using it that way. The next is the setup for the buttons, and so here this is some seesaw stuff. The button definitions are actually on pins from the seesaw, and I can name them whatever I want. So typically this is actually the button right. If you have the joystick featherwing turned this way, pin 6 would be called button right. It's also called pin A on the silk screen there. So if I orient it this way, then I'm going to have 6 be up, 7 be right, 9 be down, 10 be left, and then the select is pin 14. This little message here, this button mask, is the sort of single message that gets chucked over to the board via I2C on Seesaw to say, here's the status of the buttons. So there can be multiple presses simultaneously with that. Then we have those all being set up as pull-ups on Seesaw, so SS is Seesaw there. And then these are some variables that I'm using to keep track of the state of things. Actually, I don't think I'm using frame anymore, but tab number, which tab am I on, and the sort of sub-screen within the tab number. So we start off at 0, 0, so it's the first tab and the first image on there. And then this is the function that kind of does the heavy lifting. So this is, I define a function called image switch and a direction. So is it going to the next tab or the previous tab? Is it going to the next screen or the previous screen? So there's essentially 4 directions, and I'm using a 5th one in kind of a cheesy way here for my toggling of the palette to amber. So since I'm using these outside of this function, I need these to be global. This one, actually, I can hide that and not use that. I think that'll still work. Let's see. I don't think that's necessary. But the tab number and the sub number, those get used when I'm pressing buttons because I want to send to this function those values. And so when I press a button, it will call image switch as one of these direction arguments, 0, 1, 2, 3, or 4. So if I send it the 0, if we scroll down here and look at what's happening when I'm sending button presses, if the button gets pressed, so the value goes low, because these are pulled high, on the right button, so that's this one here, that went to the next tab. Why did it do that? It's because I'm setting it to say image switch direction 0. And I could even use that named argument or keyword argument just to sort of document the code. So direction equals 0 there is going to send this function image switch 0, so it's going to find, oh, if direction is 0, here's what we do. The tab number, which was originally a variable that was 0 when we started the program, becomes tab number plus 1, so it increments it up, and then we do the modulo of the however many of those screen maps we have, so the length of screen map. So that's these, I think, 6 or 5 tabs that I have, 1, 2, 3, 4, 5, 6 tabs. And that's what means it'll wrap back around to the beginning. So that's why we're using that. And thanks for people's help last week in getting my modulo math or syntax correct. I had it messed up before. Left will do the -1. If I'm sending a direction of down, it's going to go and grab how many of those screen tabs do we have, those subs of those, how long is that list, and then it'll do it in the negative if we go up or down. And then the last one here is this cheesy one for palette swap that I'm using that I'm not happy with right now, so we'll kind of ignore that. Again, in just trying to stomp out bugs, I'm doing some garbage collection. And then the image and palette get set to be whichever one of these images we have just asked for by virtue of which button we pressed. And then it shows that image, does a little garbage collection. If the color toggle is on, then it runs that palette swap on it. And it happens pretty much instantaneously before it draws, before we see it. Then joystick stuff. So here's the cursor stuff. So we have a value of 0, 0 for our state to sort of remember where the joystick was, and then we'll be updating that so we can tell if there's a change. And this is what prevents us from constantly spamming the serial port with print statements or updating it constantly. Allows us to only adjust when it moves, and this kind of keeps the cursor from jiggling, which you'll often see if we're not careful about that. So if we look at the device here, let's see. We got a. These are more likely, by the way, when I'm plugged into USB, I've noticed. So that's something I'll mention to Scott and Dan. They seem to happen more often when I'm plugged into USB, which makes debugging not fun. So let's look, though, at the joystick function here in the main loop. JoyX is a variable that gets created by asking the seesaw chip over I2C to read analog 2, which is this way on the joystick in the orientation that I have it. JoyX is in this direction. And then this is what checks to see if anything changes on either one. If the absolute of JoyX minus the last joy value, which we'll then update when we need to, or Y happens, then that means something has changed. And if my cursor is being told to draw, then I'm going to set the cursor's X value, so cursor.x, to be an integer of this map range. Remember, I imported from Simple Math map range. So map range takes the joystick X value, and it goes from 10 to 1023, which are just by experimenting, I see that's really the extent of what I'm getting on this joystick. So it takes the minimum of 10, maximum of 1023, remaps that to 0 and 264, so that's left to right of the monitor without the cursor running off the side. And up and down goes also from 0 to 1023, but to a different set of values, and I've also inverted it, so it goes from 224 at the bottom and 0 at the top. And then we reset those state variables here so we don't update this when it's not changing. And so that's what gives us this nice joystick action here. And you can do kind of cool stuff with this. If, let's say, you only wanted the joystick to be on the left half of the screen, you could simply map either just half of, let's just do it this way, let's just map this divided by 2. So I'll do int divided by 2. And also, by the way, when I'm working on this, I turn off this boot sequence because it has to happen before I can see the joystick. So when I'm working on this, I'll turn off that little boot sequence, which is, let me show you where that lives. Right here, it's the last thing we do before the main loop of the program runs, and that just says we're going to load up each image from the array or list called boot file names, which is this list up here. So that little list there, and it's just going to run each of those for, I think, a half a second or 3/4 of a second. So if I don't want that, I just comment that out. Right now I don't have a switch for that, a debug switch or anything like that. But if I just go whoop, like this and save, now watch when it relaunches. It won't run through all that boot stuff. It'll just go the first image, which I kind of have hard-coded, and then it'll go jump straight to one of our screens, unless it's hung. Has it hung? Or is it waiting for me to move? Yeah, sorry. It was waiting for me to update it. So now my cursor only goes halfway, which is kind of cool because you could imagine that maybe your screen area that you're going to use functionally is only a portion of this. You could kind of leave it inside of a little list or something like that and adjust where the center is even of that. I think I just wiggled something and made it restart. So yeah, so in this case, it never goes to what we think of as the first screen until I press a button. So it'll stay on that Pip-Boy screen. There we go, and that's just updated. So let's go and fix that back down to the way it was. It's not a bad idea also to set up variables like screen width as a number so that you can then just say half of screen width or half of screen width minus cursor width, those kinds of things. It makes it a little more portable code if you end up using a different display, but everything else you want to stay the same. And then the rest of this is just the button presses. And you'll also notice, by the way, I change this value sub number. When I go right or left, if we had already gone down into the number of screens, let's say we're on the 5th screen of the first tab, when I go right, I just want to jump to the top. I don't want to stay at that level, or that level might not even exist if we don't have an equal number of sub-screens. So I just set that sub value up to the top, so that means we jump up to the top of the next tab, we can come scrolling down, we can jump back left, and we'll go back up to the top. And that's pretty typical expected behavior of this type of menu interface. If you think of the back of a digital camera or your set-top box or a TiVo, that kind of thing, you tend to have drill down, but if you go right or left, you'll jump back up to the top. So that's how I did that. All right, I think that covers it. So that's what this little gizmo is up to now. I can go to this nicer full screen of it. There we go. I'm really happy about it. Let me know if you have ideas about some of this cursor stuff. It's a tight little joystick with spring return, so it could be that you don't want a real cursor on there like a mouse, but instead just use it to kind of wiggle up and down through menus, that kind of thing. could be cool as well. If we can rotate or scale things on here, if it's fast enough, it might not be. This might be another good interface for that. I'd love to see someone write some games on this too. That would be super, super cool. So let's see. Let me check in with the chat. Rebecca Wilson says, thank you for the info on the show. Sure thing. Happy to help out there. And over in our Discord chat, there's some nice graphic from, what is that? Oh, this little GIF. Yeah, I think there's like a watch version. Oh yeah, the animation is great on that. Love that. Static images. Yeah, I had done an animated version of this, but the update, the frame rate is just not going to get that fast inside of CircuitPython the way I'm doing it. Maybe with a sprite sheet, we might be able to animate it a little quicker if I have a single image loaded that it's just jumping between sections of. That'd be super cool. Let's see, what else? JKD is the one who asked the question about the latching relay. Just ordered one, which should be in the UK in a few days. Okay, don't break it if you're only getting one. I'll sacrifice one if you don't want to. We'll try that out. So maybe we'll do that when I get back. And let's see, last thing I wanted to do, I just need to kick this camera back on over here because it shut down due to the heat. Because, yeah, it's still hot down here in Southern California. I'm pretending it's not by wearing a long sleeve shirt, but I'm going to turn on my AC so that camera stays happy. And I just wanted to show you a little quickie build thing I was working on. Let's see. All right, that should work. And let's do the bench cam in the corner there. So I was working on some props for a play, and I did essentially some magic wands, Harry Potter style wands. And one of the versions that I didn't end up going with, but ended up being kind of useful, is I had a mini mag light, and I wanted to give it a easy to use switch, not the little screw end, because I was planning to add the extra wand parts up the top. So I needed some extension there and an LED on the end. And this is actually how I did the other ones. They use pen lights, and maybe if I get those back after the show, I'll take it apart and show you. But this is essentially taking the mini mag light as it is, but I've removed this is an old school one, so this is a little incandescent bulb. This is the reflector top part, and normally this is screwed all the way down to be off, and then as you unscrew it, it turns it on. And the way that does that is there's a little spring-loaded disc here that increases or decreases its distance from the contact. So that means with this unscrewed, it's on. So I just ran some a switch, one of our little clicky switches with JST connectors, off of those. I just was able to fit two DuPont connectors right into the ends there, and then use some heat shrink to hold it all in place. And that means we've still got access to the back here to change the batteries out. This one takes a couple of AA's. AAA mag light, mini mag light would work better for a wand. This was just too big. And then in this case, I've just plugged a big 10 millimeter LED into it. And this is on the border of how much voltage this wants for this white LED. So you might need to put a resistor in line for different colors of LED. But it's kind of a fun way to have a bodged together battery pack that you definitely don't want to try to bring on an airplane, that's for sure. Let me switch views here so you can see that a little better. And yeah, with some extra housing for that to look like a wand and some little diffusion on there, you get kind of a cool way to make a really robust battery pack. You could do it other ways, of course, but this was what I have on hand, switches and big heat shrink tubing version of a pretty sturdy little battery box. So that's that. I just wanted to show that off because I thought that was kind of fun. Let me know if you've got ideas on other fun mini maglite hacks. I've had these around forever in my life, and they're always Amazing how inexpensive they are for such a well-made piece of aluminum gear. I think they're aluminum. All right, so that's my little mini hack thing there. Yeah, lightsaber in the works. It's true. I even somewhere over here I have a. I showed this off before. A really old flash bulb holder. This is a battery pack from a flash bulb for an old camera flash. But it's essentially the same thing. This held dry cell batteries that go in here. This is something that went on a somewhat standard mount on the side of a camera. Flash bulb went up here. Trigger was a remote switch that I think you connected to your shutter so that it would pop the flash. But I've done similar things with this one. I've built that into a power supply before as well. All right, well, I think that's going to do it for today. Thanks, everyone, for stopping by. And I also wish you a very happy Thanksgiving next week. I will be off next week visiting family and doing Thanksgiving things. Hopefully wearing flannel and doing the crossword puzzle and drinking hot toddies if I have my druthers. And I will see you the week after that. So take care, everyone, and have fun making stuff. And thank you all for stopping by. Bye-bye.